Welcome to unit tests for the Death Star. This talk came about because I woke up from a dream the other night, wondering how many unit tests it would have taken to validate the code that runs the Death Star. It was a strange thought, but it gave me something interesting to wrap this talk around. So, as this implies, we're talking about unit tests in particular. Good unit tests are a critical part of the development process, vital to the life cycle of any code that's under test. With a previous employer, I wasn't allowed to write tests. I explored a little bit, but in my manager's mind, there wasn't enough time. The code was flaky. It didn't stand the test of time. That code is not out there in production anymore. With my current employer on a previous project, I had come onto the project and realized that the elephant in the room was the script language that ran on a mainframe that we had to duplicate in browser. So within JavaScript, I had to actually create a language. Throughout that process, I built the language up and realized that what I had was not something I'd be willing to give to a client. My employer was more than willing to let me rebuild this. And when I rebuilt it, I rebuilt it with full unit test coverage. In fact, layered unit test coverage, 180,000 lines of code, unit tests in depth. I operated with test-driven development whenever I found bugs within the code before release. The result of that was 3 bug cards that were created in 365 days. In the year that this was in production, 2 of those were simply missed requirements, things that the client had given me wrong information on. I've also seen cases of 2,000 plus unit test cases against promises in JavaScript that passed at all times, even when the test should have failed. I've seen no tests or limited tests on monolithic code, functions that are 3,000 to 6,000 lines long. How do you comfortably break that up if you don't know exactly what it's supposed to do? Nobody is going to know what that 6,000 line function will do from beginning to end. So I want to reiterate, good unit tests are a critical part of the development process and vital to the life cycle of code under test. So I want to inject a little bit of testing humor into this. I have operated as QA. I'm not picking on QA on this part, okay? But I actually had to write this Beers on the Wall Sing module. Just had to do it. It was one of those things that popped up. So what are unit tests? Unit tests exercise small parts of the application, what I keep referring to as code under test. They should operate in complete isolation and test actual behavior versus expected behavior. Unit tests should be fast, simple, and stable. They should reflect the specifications and can be a form of documentation. They are a safety net that provide immediate feedback about code changes. They allow us to find and fix bugs earlier and allow us to contribute to higher code quality and better architecture, as well as faster detection of code smells. So here's some of the talk details. The code repository that will have this code is on my GitHub account, Bob-Fornell. What to avoid when writing unit tests, which was the original title for this talk. I can be found at linkapp/conference. On Twitter, I'm at rfornell. I write articles at DevTO under, again, rfornell. And on LinkedIn, rfornell. Okay. Testing code has been described as an art form. It is, but it shouldn't be. There are many good patterns that should be followed when we write tests. There are also as many bad patterns that developers should be aware of so they can avoid them or clean them up. And that's the core of what we're going to talk about here. So good production code achieves encapsulation. Not talking unit tests here, talking code. It allows the reader to navigate large systems with ease, diving down into the details, rising up to higher levels of abstraction as needed. But testing code is a different beast. A good unit test is often small enough that a developer can conceptualize all the logic at one time. Adding layers of abstraction to test code simply increases its complexity, makes it harder to read and understand what you're looking at. Tests are diagnostic tools. They should be simple and as obvious as possible. So what is well-factored code? It's code that's easy to read and reason about. Well-factored code is code that's abstracted, that has things shared between components where it's appropriate and those kind of things. It allows for very complex code to be managed well. Tests should not be well-factored. And here we're talking about two different things. Okay, so keep readers in the test. If we have a function that returns a score, the problem can often be that we abstract away some portion of that unit test in a way that makes reading the test difficult. The second portion here is we want to dare to violate the try principle. We want to duplicate logic. Okay, that same function that returns a score, if we've abstracted some part of it away, it becomes hard to read. At its simplest, if you've got something significantly lower down in your code that references something hundreds of lines above it, thousands of lines above it in the test suite, you're bouncing all over the place to figure out how that code works. Okay, let's take a look at keeping the user in the test. For both test suites here, we're going to use the same set of code. We've got an export class of manager. We're setting up data. As we knew this up with our constructor, we're passing something in, database, an array, okay? Nothing real complicated. We're attaching that to data. We have a get score that filters based on username. We have an adjust score that filters based on username and then changes the zero index score value. So if you had multiples, it wouldn't work. But this is just to show us keeping the user in the test or not keeping the user in the test. Okay, so let's take a look at not. And while we do that, let's do this. We'll open that up. And we'll open this one up to the side so we can see these side by side. We bring in the manager. We're setting up our class. We do a let manager, and in the before each, you can see here, we're newing up the manager, passing it in the database. Okay. Our database array is really complicated. We're passing a username Bob 54321 and a score of 200. Okay. And then down here, we expect the score to be 200. We get the initial score, and we expect it to be 200. This does not seem like a problem. But what I want to point out is keeping the user in the test. Let's say we had several thousand lines before this actual test, right? We're just going to make it about 100 or so. And you come down here, if I look at this code, where does this magic number 200 come from? I have to scroll back up, and I'm going to do it kind of slowly here. Scroll back up. Say, oh, look, that was 200. We're not keeping the user in the test here. This becomes a difficulty as your test suites grow. I'll close that out. I'm not going to save the changes. Let's take a look at this done a little differently. And let's pull it to the side so we can see both side by side again. Again, bringing it in, we're not setting anything up, not in a before each. Okay. We expect the score to be 200. Look at this test. We're setting up our database. We're newing up our manager class, passing it that database. So now when I see get score and I look at this 200, I know exactly where that came from. There's no ambiguity here. Keep the user in the test whenever possible. Now, let's take a look at violating the dry principle. I'm going to keep everything in one suite. We're using that same manager class we had before, so let's open that up. And let's open up our nut spec to the side and take a look at what we have here. We're bringing this in. We can see it's the previous one we used. We're setting up our test suite. We're breaking things a little bit, right? Keeping the user in the test. We're going to break that a little bit here just for simplicity. Okay. We expect the score to be 200. We've seen that before. We're adjusting the score. We have to get the score after we adjust the score to see that it now equals 500, that actually worked. The coding paradigm of do not repeat yourself, right? We set up a before each, so we didn't have to repeat this whole setting up the database and setting up the manager within our test suites. We abstracted. And actually, in the long run, we'll make this test suite much harder to manage. Let's take a look at this in a fixed pattern. We've seen this before. This is where we fixed our keeping the reader in the test issue. And keeping the reader in the test does the same thing down here. We can adjust the score. We can pull that score to check our results. Much easier to see everything that's going on for this particular test. I'm not advocating for removing your before each or after each. There's a lot you can do there. In this particular case, we set up a pattern that can showcase these failures, these potential problems. The next thing we're going to talk about here is poisoning the code base. In this case, we're talking about non-deterministic factors, a lot of big words that basically say things that are hard to determine in advance. So a function that returns a category given the time of day. The problem here is that time of day is tightly coupled. It's a tightly coupled piece of data that we have to do. We have to jump through some layers to isolate that within our unit tests. Okay, this violates the single responsibility principle. Tests can't easily test that functionality that we're talking about within our code under test. Okay, let's take a look at some non-deterministic issues here, and time is one of the biggest ones, right? So let's take a look at that, and we're going to use a get time of day function. It's going to get the date, pull the hours off of that, and return a value of night, morning, afternoon, or evening based on time of day, right? Based on this time of day. Doesn't seem like a really complicated piece of code. But when you get into this in a test suite, we have to do some major jumps, major hoops here to, first of all, I've found the Jasmine clock doesn't do a really good uninstall in a before each, after each kind of setup. So I always put those in my tests. So you uninstall, then you reinstall. We set up a date with a time. We mock that time. We move our clock forward a little bit from that time. And since our time was like 2 a.m. here, we moved it forward 50 milliseconds from 2 a.m. We're between 0 and 6, which is going to return night. Non-deterministic. We have a date in here that's hard to determine what the date and time is going to be, right? The date and time is going to be based on when the test is run, not based on something we can control easily. So let's take a look at controlling this easily. So if we come over here for the time not, and we look at a modified set of code. So here, we don't calculate the date time within the code. We simply take an hour and use that as our basis to determine which one we return. Now, from a test perspective, our tests become really simple. And yes, I could write one for all 4 of these. I probably should, right? But you can see we pass that 2 in for the time. That's the hours that we tested previously. And we see that night comes back. 1 line of code to be able to test this, as opposed to that heavy wrapper of controlling the date time. Okay. So non-deterministic. Take those non-deterministic values out if you possibly can, pass them through. It will change how you write your tests a little bit, and that's a good thing. It'll change how you write your base code a little bit, and that's a good thing too. The next type of poisoning we want to talk about is poisoning the code base with side effects. So if we're given a function that updates the time of the last motion, triggers something off or on, a light bulb, let's say. The problem here is there are a lot of side effects that are kind of built into that process, and those side effects cause all kinds of problems. And this is going to be easier to see in code, but those side effects make it very difficult to wrap tests cleanly around that code under test. All right, let's clean this up. And again, we're going to take a look at the next one here, which is side effects. Okay, we're going to take a look at this controller, and side effects is a little bit more complex to see. So we're going to look a little bit heavier code. Now you see we have our get time, get date time, get time of day function that we used previously. We have a switcher class that allows us to turn something on and off. A light bulb, let's say. Okay. Our smart controller brings in a last motion time, and here's our date, one of those that causes problems. And our constructor, we're bringing in a newed up version of switcher, and we're assigning it so that we can use it later on. Okay, we have one other function that we're really dealing with here, which is the actuate lights, and it takes motion detected. If the motion was detected, then it's a Boolean value. Then our last motion time gets set to our current time. So here this is what we saw previously in our non-deterministic, right? Causing side effects. And in addition here, we have to get the time of day, passing it the hours that we have to up here. And then we have our motion detected, and time of day is evening or night, or time minus last time is greater than 60 seconds. So if there's motion greater than 60 seconds, it's in the morning or the afternoon, or it's in the morning or the afternoon, we turn the light off. Okay. Somewhat convoluted logic, and actually made more difficult because of these side effects. So let's take a look at what it takes to test this as is, right? So we'll open this up. We set up our switcher, we set up our controller, we're passing it in as we knew it up in the before each, okay? Side effects, getting code to work right. We had to set up a clock, just like we've done before, okay? We get a last motion time. We get a current motion time, and you notice these are almost exactly the same except for the minutes, greater than 60, right? We set our clock to our mock date. We set our last motion to our time, our last motion time to our time from our get time, okay, from our last motion time. We spy on our switchers. We actuate our lights. We pass in motion detected false. So this is not going to reset here. It's going to be false here, so it's going to go through the else block. So it should turn the light off, and turn off is what we expect, right? So in our secondary one, we have the same date time, setting up our same clock. We're setting up our same current motion time. We're setting up our last motion. We're spying on the same, but we're passing in true. Okay. And true, when we pass in true, we're resetting our time to whenever the test runs on the get time, right? But we mock the clock, so we've got a rough idea when the time is. But then we're checking the time of day, and our hour is 19, which should put that in the evening, and it is evening, so it should turn the light on. Okay, this is really complicated to read and understand, isn't it? I mean, we're jumping all over the place to follow the test in the suite. So let's take a look at a rework of the controller and see what we did here. So our switcher is the same, last motion time is the same, and passing in switcher is the same. Get time of days, nothing's changed there. Now, I have created this get time, get hours function. Nice to have those separated out, pulled out, so that we can spy on them and potentially control the data that they're passed in to reduce some of these side effects. Notice we don't need to get the time up here in our actuate lights. We bring in the motion detected, we update to the get time, and if we spied on it, we can control what that value becomes. Our time of day is based on get hours. This is this get hours function that we have up here. And again, we can control what that pushes through to get time of day. I've reworked this if logic to be a little more readable, right? Evening or night, an array of evening or night includes, and I probably should pull those out, make that a little even further, read that, make that more readable, take it another step. But simplification, okay? And then in our else, we have the same logic here, except we're using the get time compared against the motion time. And we're using that same logic for the if over here for the includes, okay? Just to clean up. All right, so remembering what our test suite looked like previously, let's take a look at our new one. Okay, they're still a little lengthy. Our setup's the same, but they're not nearly as bad. And 0 Jasmine clocks. Okay, we don't have to do any tweaking on the clock. Doesn't matter if it's Jasmine or Jest or whatever. Here, we don't have to do anything with the clock. Okay, we spy on our get time, get hours. We control the values going through. We spy on our turn on, turn offs. We actuate our lights using a false. And then we just have check see if it turn on or off. We control our values. Turn on or off. Okay. Reducing those side effects simplified our logic and our ability to write the tests fairly significantly. The next problem we want to talk about is testing too much. Function that does too many things simply has too many paths through to be able to handle it easily, to handle it cleanly. Okay, there are many ways to reduce that amount of code down and reduce the amount of paths through to make testing a little bit easier. All right, so let's clean up again. And let's take a look at testing too much. Okay, so I'm creating a messaging service here. And this messaging service sends an email, a text, or a queue. We can trigger a message, and based on the type of user, we can send a particular message. All right. And additionally, we're looking at this preferred notification message and sending email, text, or queue notification. Testing too much. What are we doing here? We've got one function, trigger message, that has 12, 4 times 3 routes through. That's a lot to test. Okay, let's take a look at our test suite here. Okay, we're testing admin. Now, if we notice, we're testing admin 3 times because we have to test for each of these send types. Okay, then we're testing user. We're testing user 3 times, each of the routes through. We're testing author 3 times, each route through, and anonymous 3 times, each route through. About 100 lines of code to test about 30 lines of code. Okay. This is a lot. You're trying to test too much at one time. Okay, let's take a look at how we can rework this messaging. So I set up the sends, email, text, or other. I set up messages, admin, user, and author anonymous. Okay, these are just JSON objects at this point. Okay, the sends actually are functions we can trigger. We have a get message. You get the message type, or you send anonymous. So it could be admin, user, author, or anything else fires anonymous. We have a trigger message type. Okay, now realize on the get message, we have 2 routes through. Trigger message type. You pass it a type, you pass it a message. If the type is text or email, you use the send for email and text, right? Sending it the message. Or you use other. So again, 2 routes through. And then our trigger message simply gets the message and triggers the message type. Uses those 2 new functions, and so that has 1 route through. We've now reduced our code complexity from 12 to 5. Total class complexity, okay, not individual individual modules. So let's take a look at testing this and see what this looks like. Notice the size difference right off the bat, okay? The setup is about the same, okay, we're spying on. But our test suite is radically smaller. We test get message, 2 routes. Trigger get message type, 2 routes. Trigger message, 1 route through, tests all of it. Okay, be careful that you're not testing too much. If you're starting to write dozens of tests against a single function, maybe that function's too big. Maybe there's too much going on that you need to account for. So the next issue here is a bad test double or testing the mock. This is one that I see all the time when I'm reviewing code. A mock service is created that allows functionality to be isolate that functionality out. But in reality, in a lot of cases, we end up actually testing the mock. A better pattern is to create a mock service from the original service being injected. That way, if that original service changes, we're able to understand what's going on and see our tests fail as something below it gets changed. So, if we're given a service to get some data, replacing that service with a test double does not necessarily take into account changes in that original service or the data that's returned. All right, let's clean this up and we'll take a look at our next pattern here. And we're going to take a look at the bad test double. So in here, we're going to use a single service. Okay. We have a data service that's used by a test component. Again, we're passing it in, so we have that API service available, and we're using an API service to get simple. Okay, so bad test double is pretty straightforward. What I'm doing here is we're setting up a mock service, mock results. In before each, I set up what my mock results are. I set up a mock service that has a get simple, and it returns the mock result. I pass that into our test component. All right, the problem here is pretty straightforward, I think. We're testing this mock service when we test get data. We're not testing the original data service. And if something changed over here, if there were some modification of the data or something like that, let's say this converted to uppercase, this is never going to account for that. These tests will still pass, whether we wanted them to or not. If we forget to update our mock, causes problems in our test suite. So let's take a look at how we can adjust for this, account for this, okay? So I bring in, notice in the first one, I only brought in test component. In our new one, I'm bringing in data service and test component. I'm still creating a mock user. I new up our mock service, and then I change our data so that our get simple returns that mock data. So here, if something changed in get simple, that would reflect on our tests. Okay, this is an important thing. And I see people using the mocks too heavily, testing the mock quite often, actually. Just something to be aware of and be careful of. So false positives, if we're given a function that processes the time of day, the unit test doesn't get to code the test inside a set timeout or something like that, it's possible it couldn't fail, or it may not fail ever. This equates to a pass. So, sorry, I said time of day, I meant time delay. Okay. Set timeouts can cause all kinds of problems if you're not careful. These occur in a couple of cases, false positives, that is, not just set timeout timing delay, but when we forget to write an expect. A lot of test suites will warn when there's no expect within a particular test. Not always. When we're testing asynchronous activity, promises may not have failure written into them. At one point, Jasmine used a done keyword that was passed in on tests. And I've actually seen that that's fairly unreliable at times. They're improving it significantly, and that's good to see. JavaScript does allow for async await and try catch. And those patterns are simply more readable than promises. And async await can be used within the tests too. Okay, so false positives. All right, let's clean up again. And we'll take a look now at testing our false positives. Okay, and let's take a look at some false positives here. And I've run these, you can pull the suite down These will pass whether you expect them to or not. Okay, I set up this testable code, and it's a little complex. It's a little nested thing here. Okay, testable code has a get rejected promises key. That's a function. Okay, this function returns a promise with resolve or reject inside a set timeout. After 1 second, it rejects, it fails. Passes fail. Okay. So with that set up, we'll take a look at our tests here. Not all of them are related to that, only the last one is. But here, take a look at this. No expects. Guess what? This passes. In some test suites, it'll give you a warning. Not all. Here we have an expect inside a set timeout, 1,000 milliseconds or 100 milliseconds. What happens? This runs, triggers the set timeout to pass it off to be run 100 milliseconds later. Then it says, hey, I'm done with the test. 100 milliseconds later, it pops up and says, hey, I expected true to be false, but the test is already finished, so it doesn't care about that. It ignores it. It gets swallowed up. Here, we use that get rejected promise. We set up a then with a result, and inside there, we expect it to equal failed, not fail. What happens? Well, because the promise is wrapped around it, the test finishes before the promise completes. Again, the error that we should see, the failure of the test that we should see, gets swallowed. Okay, let's take a look at the same code and what we can do to fix these. It's pretty straightforward. Put an expect in, right? If you have no expects, put an expect in. Set timeout. We've got to set up our clock, right? We execute, we initiate our set timeout, and while it's off and running, we move our clock forward 110 milliseconds. So that set timeout comes back and says, hey, we're done. Now we can check our result. Okay. Surprisingly works. It could test failure just by changing that to false and see what happens. Make sure it fails, right? And then expects the rejection to occur. Again, we need a clock. We set up a wait promise. Okay. We tell it, hey, we're triggering this. It's going to return a promise. Okay. So what are we returning? We're returning this. This is what gets attached to wait promise. Okay. It's triggered that set timeout so that when we set our tick to move forward 1010 milliseconds, this code inside fails. Okay. So our result then awaits that wait promise. We wait for it to be finished. We get our result. A result would be that fail coming back. And you can check this, just change that to failed, change it to anything else other than fail. And you should see this test fail. Because what happens? It rejects. That rejection kicks us out of the try, which puts us into the catch block so we can test the error that comes through. Kind of a weird way to test that, but it works. All right. Several false positive failures, and there are others. Okay, please always test that your tests actually do fail, especially as your test suites start to grow. So excessive setup. When a unit test needs a lot of setup code to run, that's what we're talking about here. This isn't necessarily a quote unquote problem. Okay, excessive setup is more of a code smell than something where code can be shown to be correct or incorrect. This is a case where care needs to be taken in examining why the setup is so lengthy. There may be a legitimate need to have that large of a setup. And generally what I'll ask my developers to do that I work with is, let's add some documentation. Why are we doing it this way? Okay. If your code under test doesn't adhere well to the single responsibility principle, maybe a refactor would be appropriate to make it more testable. Okay. So the last one we're going to talk about here is testing private functionality directly. And this is, again, this is one of those kind of grayish areas. If we're given a class with private functionality, it can be difficult to test it indirectly. So how do we? And some of the solutions that I discuss with folks are testing indirectly, which can be challenging, which means you're using another function to trigger that function you want to test and seeing the results based on what the original function does or how it responds. You can make it public and test it directly. That's an awkward one. It bypasses that whole reason to make them private. We can abstract it into a new service to test directly through that new service. And again, you're making it public in a way that you may not want to. Now I have this fourth option, and this one applies to front end. And if you're doing back end, I don't have a solution there. And this only applies for TypeScript, even though it's a JavaScript option, TypeScript / JavaScript, they're kind of meshed together in many environments. But what I found in TypeScript in one of these talks that I was doing, and this was just before I gave the talk, that night, I ran into an odd scenario where the square bracket notation to reference a module or an attribute within a class, as opposed to the dot notation, that square bracket notation bypassed private, which I thought was kind of weird. So I actually went back and set up a JavaScript class with a private using hashtag, which is now implemented in JavaScript. And there was no way to bypass that one. And while I gave that talk, somebody actually looked it up and figured out that the TypeScript team had left that square bracket notation in as a bypass, essentially as a backdoor specifically for unit testing. Okay. And I have to make sure always to be on guard that the developers that I work with aren't using the square bracket notation inappropriately, that they're only using it for testing. But for front end, that's a way to do it. I don't know if there are routes to do that for back end in, let's say, Java or .NET or something like that. But certainly if you're doing Node, if you have TypeScript included with the Node, that gives you a way to test those privates. Okay. All right, so let's clean up, and we're going to take a look at one more set of tests here, and we're going to look at testing private. So first thing we want to check on testing private is this user class service. Okay, user service has users. This is JavaScript notation for private. And you see we can use this user all through it. Set state is also private. There is no way around this. There's no backdoor on the JavaScript private. When it's private, it's private. It can only be used inside this newed up class. Cannot in any way be used outside. So to be able to test this, these are the only three I'm going to be able to use. Well, four, because we have a visible set timeout timer here. Okay. Our test suite for this. There we go. Let's open that to side, take a look at what we're doing, okay? So I originally had not had the visible set timeout timer handler in here. That's where this code comes from, but testing it privately, okay? We have to use the set user state to test our set state. We have to use this visible timeout to determine what's what's going on inside this delayed process. We have to use two user set states, okay, set user states, because we have two paths through our set state. Okay, this is a little counterintuitive. Now, I am going to spend a little bit of time here showing what we can do with TypeScript. Okay, so whether you have TypeScript in your Angular, in your React, whatever, if you're using TypeScript, it gives you that backdoor, and the backdoor is pretty cool. I'm not going to show it here because I don't have TypeScript up and running in this repository. I only have JavaScript on my repository, but I'll show you how that works. So, unit test recommendations. Unit tests should be readable. Number 2, one assert per test method. I get asked about this one quite often. Even in my tests, I have more than one assert quite often, but it's usually wrapped around one concept. Okay. Your function may not be as isolated as it needs to be if they're not kind of wrapped around one activity. Okay. Avoid test interdependence. Your tests should be able to run in any order. If they can't run in any order, if they have to be in a specific order, your tests depend on each other. Something's clearly wrong there. They should be short, sweet, and visible. I push to get tests at their largest to fit on one screen. Okay. And please, please, please add your tests to the build. They need to be part of your CI/CD process. They need to be blocking PRs, merging code in, things like that. That's very, very important. And thank you for coming to the talk. I hope you enjoyed it. I hope this was what you expected it to be.